Hari ini kami akan mempresentasikan mengenai electroplating yang disusun oleh kelompok 1, yaitu ada Septa, Kidam, Rizky, Sena, Dipo, dan Aji. Kami dari Teknik Metalurgi Universitas Sultan Ageng Tirtayasa. Ini adalah outline yang akan kami presentasikan. Yang pertama ada pendahuluan, electroplating, kesimpulan, dan daftar pustaka yang kami gunakan. Oke, yang pertama, apa sih itu pelapisan logam? Oke, pelapisan logam adalah proses untuk memberikan sifat tertentu pada suatu permukaan benda kerja, di mana diharapkan benda tersebut akan mengalami perbaikan, baik dalam hal struktur mikro maupun ketahanannya, dan tidak menutup kemungkinan terjadinya perbaikan terhadap sifat fisik. Langsung aja nih kita lanjut ke electroplating. Electroplating merupakan proses pelapisan logam dengan menggunakan bantuan arus listrik dan senyawa kimia tertentu guna memindahkan partikel logam pelapis ke material yang hendak dilapis. Adapun electroplating untuk kegunaan dan kerugiannya, yang pertama untuk kegunaannya memperbaiki tapak rupa sebagai protektif untuk logam, meningkatkan ketahanan produk terhadap gesekan, memperbaiki kehalusan bentuk permukaan logam, dan electroforming. Untuk kerugiannya, adanya keterbatasan dalam ukuran lapisan dan desain. Yang kedua, hanya bisa dilakukan di bengkel, dan ketiga ada terbatasnya dengan bahan yang bersifat konduktor. Adapun faktor-faktor electroplating, yang pertama, temperatur larutan, kuat arus dan tegangan, waktu pelapisan, konsentrasi larutan, dan pH larutan. Nah, pada electroplating terdapat arus listrik, katoda, anoda, hukum Faraday, dan larutan elektrolit. Berikut adalah prinsip dasar dari electroplating. Yang pertama, anoda yang tidak larut berfungsi sebagai penghantar arus listrik saja, sedangkan anoda yang larut berfungsi selain penghantar arus listrik juga sebagai bahan baku pelapis. Yang kedua, katoda dapat diartikan sebagai benda kerja yang akan dilapisi. Yang terakhir adalah elektrolit, berupa larutan yang molekulnya dapat larut dalam air dan terurai menjadi partikel-partikel yang bermuatan negatif atau positif. Berikut adalah mekanisme terjadinya pelapisan logam. Ini adalah reaksi yang terjadi pada katoda, yaitu adanya pembentukan lapisan nikel, pembentukan gas hidrogen, dan reduksi oksigen terlarut. Sedangkan pada anoda, reaksi yang terjadi adalah pembentukan gas oksigen dan oksidasi gas hidrogen. Ada lagi nih, salah satu contoh dari electroplating. Let's check this out.
Objects made from these metals seem to be everywhere. But in most cases, the metal on the outside of these items is just that, only on the very outside. It's put there by electroplaters like us. Hi, I'm Rob Legg from Precision Plating, and I'm going to show you how. Electroplating, or coating an item with a thin layer of metal, involves dipping an object that can conduct electricity into a solution that has dissolved metal in it, and passing an electrical current through both of them. The current causes the object to become negatively charged, while the metal ions in the solution are positively charged, so they're attracted to each other and the metal deposits on the object. But why put a layer of metal on an object at all? What is the point of electroplating? Well, it can give an item a desired property, like resistance to abrasion, protection against corrosion, or a certain visually attractive finish. So what sort of objects can we coat? Those made from a large range of metals and a few types of plastics, but because everything we dip into solution must be able to conduct electricity, plastic items must first undergo pre-treatment before their surface will carry a current. To pre-treat plastic parts, we first have to process them through 4 different solutions. Each of these solutions will treat the surface in a different way without the use of electricity. The first solution is acidic. It etches the plastic so the layers we add on top afterwards will bind to it properly. The second and third solutions give the plastic parts an even coating of atoms of a metal palladium. And these allow the final pre-treatment layer of electroless nickel to grow on top. The metal-coated plastic parts can now conduct electricity and be electroplated in the same way as metal parts. Now, electroplating itself isn't a one-step process either, as most metal finishes require other metals as undercoats. For example, to achieve a chrome finish on a part, you first need to coat it with copper and then nickel. The copper layer makes the surface bright and level, and the nickel protects the copper and provides corrosion resistance. The same undercoats are required for parts with gold and silver finishes, so we add them more often than not. With all overcoat metals having bright and satin variations, and some having colour variations too, the range of finishes an electroplated product can have is huge. They're used in bathrooms, kitchens and sheds, offices, shops and art galleries and on planes, trains, boats and cars. Now you know a bit about how electroplated items are made, you'll probably start seeing them everywhere you look.
The idea of electroplating is like this. Okay, let's say we have a key. And then we want to electroplate this key. Okay, let's say this key made out of irons. Okay, and irons can rust easily. We want to prevent rusting, so we want to electroplate this key with layers of copper. We want the copper to cover the surface of these irons. So the idea is we use copper metals. Okay, the atoms of the copper metals will go to the surface of the key here and then stick on the surface of the key. That's the idea. Okay, in electroplatings, the very first things that we need to know is, okay, which one you take it as the anode and which one you should take it as the cathodes, anode or cathodes. Okay, so if you want to electroplate a key, okay, so should you put the key at the cathodes or should you put the key at the anodes? So which one should be the cathode and which one should be the anodes? Now here, okay, obviously, okay, because it's already labeled here, right? Okay, it's already labeled here. So the key is the cathodes, and the metals that we want to electroplate on the key is the anodes. But the question is, why the cathode should be the key, but why not? Why not the key is attached to the anode? To answer this, we need to know what will happen during electrolysis. Now, during electrolysis, the electrolyte that we use is copper sulfate. The electrolyte that we use is copper sulfate. It's the copper sulfate solutions. Now, can any of you tell me what are the ions that present in copper 2 sulfate solutions? Okay, there are copper ions and sulfate ions, right? Sulfate ions, hydroxide ions, and hydrogen ions, right? Hydrogen ions. Okay, so during electrolysis, the copper ions and the hydrogen ions, it will go to the cathode or anode. Copper ion is positive, so it will go to the cathode. Okay, so these two ions, it will go to the cathodes. Now after these two ions, it go to the cathode. Which one will be selected to be discharged? Copper and hydrogens. Which one will be selected to be discharged? Copper. Because copper is lower than hydrogen in electrochemical series, and therefore copper will be selected to be discharged. So when copper selected to be discharged, the copper ions, it will form copper atom, okay, plus the electrons at the left hand side. Okay, so it will form copper atoms. Okay, so this is copper atom or copper metal. Copper metals. So these copper metals, it will stick. Let's say this is a copper metals. So these copper metals, it will stick or deposit on the surface of the key. These copper metals. Okay. So the copper metals, the copper ions go to the cathodes. At cathodes, the copper ion receive electron to form copper metals. The copper metal will deposit on the surface of the cathodes. That's why the key must be the cathodes. Okay, the key must be the cathode. If the key is the anodes, the copper ions won't go to the anode and then deposit there. Okay, that's the reason why the key must be cathode, because the key must attract the copper ions. First, it must attract the copper ion, which is positive. Okay, and then it must discharge the copper ions. So it must be cathodes. You can ask the questions, okay, how to choose which electrolyte to use. Okay, now it depends on what you want to electroplate. on the surface of the key. If you want to electroplate copper, then we use copper, electrolytes of copper. If you want to electroplate it with silver, then you should use electrolyte that contains silver. You can use copper chloride, okay? You can use copper chloride, copper sulfate, copper nitrate, okay? But usually we use copper sulfate is because copper sulfate is cheaper.
Jadi, kesimpulan yang didapat dari presentasi kali ini yaitu pertama, pelapisan logam adalah suatu cara yang dilakukan untuk memberikan sifat tertentu pada suatu permukaan benda kerja, di mana diharapkan benda tersebut akan mengalami perbaikan. 2. Electroplating merupakan proses pelapisan logam dengan menggunakan bantuan arus listrik dan senyawa kimia tertentu. 3. Pada electroplating katodanya akan terlapisi, sedangkan anodanya akan melapisi. Berikut adalah daftar pustaka yang kami gunakan pada presentasi kali ini.